In the last video, we were able to model the average high temperature in Santiago, Chile as a function of days as we go through the year, where the days were the days after January 7th. So this right over here, day 0 is actually January 7th. But we weren't done. They want us to figure out how many days after January 7th is the first spring day when the temperature reaches 20 degrees Celsius. And I told you to be careful, pay attention to this whole notion of the first spring day. And the reason is because there's actually 2 days where the temperature reaches 20 degrees Celsius. So let's say that this is 20 degrees Celsius right over here. Notice you have this day right over here, and then you have this day right over there. And which one is in the spring or the first spring day? Well, if this is that we're in summer right over here. We're in summer right over here. We're in the southern hemisphere, so our summer is going to be when it's the winter in the northern hemisphere. Is summer. What season comes after summer? Well, this is going to be the fall. This is going to be the winter. Now this is going to be the spring. And then, of course, you go back to the summer. So we want this value, not this value. This one will be the day in fall when the average high temperature is 20 degrees Celsius. This is the first day of spring where the average high temperature is 20 degrees Celsius. The first spring day, oh, I guess it's not necessarily the first day of spring, it's the first spring day when the temperature reaches 20 degrees Celsius. So this is happening in the spring right over here. So this is the value that we want. So let's just think about that as we try to manipulate this a little bit. So we want to get to 20 degrees Celsius. So we could write 20 is equal to 7.5 times cosine of 2 pi over 365 times the days plus 21.5. Plus 21.5. Now we could subtract 21.5 from both sides, and we get negative 1.5 is equal to, and I'll just copy and paste all of this. It's going to be equal to that. So copy and paste. It's going to be equal to that right over there. Now I could divide both sides by 7.5. Notice I'm trying to solve for cosine and eventually solve for d, but we're going to take a little pause once we have this in terms of cosine. To be careful here. So we're going to divide both sides by 7.5. And we're going to get, let's see, actually, I don't even need a calculator for this. 1.5 divided by 7.5, this is 1/5. 5 times 15 is, or 5 times 1.5 is 7.5. So this is negative 1/5. Or I could write it as negative 1/5, or I could write it as negative 0.2 is equal to cosine of 2 pi over 365 times days after January 7th. Now this is where we have to be very, very careful. Instead of just blindly applying the inverse cosine function, we have to make sure which angle we are actually getting, that we're getting the right angle right over here. Because remember, we want the argument to the cosine that doesn't give us this point, that gives us this point right here, or that corresponds to this point right over there. So let's draw a unit circle just to make sure we know what's going on. And I actually do this all the time, especially if I'm trying to apply the inverse trigonometric functions in kind of a applied context where I just can't blindly plug it into my calculator. So let me draw a unit circle right over here, x-axis, y-axis. So circle of radius 1, centered at the origin. So that looks, well, you get the picture. We've done this many times before. And January 7th, that corresponds to this point right over here. That's that point right over here, that we are in the summer. Then as the days go by, our argument to the cosine increases, the angle increases. And this right over here will be the fall. So this point right over here, so we're at the fall. Right over here, and then we move on to the winter right over there, and then finally we go to the spring. This is the spring right over there. And we want the angle that gets us negative 0.2. So this is negative 1, negative 0.2, it's a fifth of the way, so it's negative 0.2, and notice, there's 2 angles that get us there. There's this angle, and there's that angle right over there. And then there's also, let me draw a little dotted line here. There's that angle. But then there's also this angle. There's also this angle, which is going even further. Or another way you could think about it, you could go backwards to get to that angle. And then if you wanted to go all the way around to the next spring, you could add 2 pi to it. So which one do we want? Well, of course, we want the one in the spring. But if we just blindly apply the inverse cosine of negative 0.2, that's going to give us this one. That's going to give us this one right over here. And we can verify that. So let's see, inverse cosine of negative 0.2 is 1.77. Remember, this is 0. This is pi right over here. So this is 3.14159. And this is 1.77. So notice it's a little bit more than half of pi, which is exactly what it gave. It gave this angle right over here. So this is approximately 1.77 radians is this angle. Is that angle right over there. But we don't want that one. We want this one. So how do we figure that out? Well, we could view it as we could go all the way around to 2 pi and then subtract 1.77. So we could say 2 pi minus 1.77 roughly to get this angle. So let's do that. So let's take 2 times pi and then subtract this number. And I'm going to do second answer. So answer is just the previous answer that I got. So that way I have good precision here. So I get 4.511. And we can kind of make sure that that's the right thing, because that's going to be between pi and 2 pi. 2 pi is 2 times 3.14159, so it's going to be 6.28 something. This is 3.14159. This is the right angle. Now, we're not done yet. That's just the angle. That's the argument that we need to give in here to get to that point. But what's the days going to be? Well, 2 pi over 365 days is going to be equal to this number, 4.511. So let me write that down. So this right over here is going to be approximately equal to 4.511. So we scroll down a little bit. We can say 2 pi over 365 times the days after January 7th is approximately going to be equal to 4.511. To solve for days, we can just multiply both sides times the reciprocal of the coefficient. So we're going to multiply both sides times 365 over 2 pi. So that's going to cancel. That's going to cancel. And now we can use our calculator for this. So that's that's actually, we got much better precision there. So let's take our previous answer times 365. We deserve a drum roll here. Divided by 2 pi. And we get 200, and if we round to the nearest day, 262 days after January 7th. So 262 days. And we are done.